4 people are in deep space right now, not orbiting Earth, not skimming the upper atmosphere in the comfortable bubble of the International Space Station. Deep space, 250,000 miles from the nearest hospital, the nearest oxygen supply, the nearest anything. And what they are about to face on their return, what NASA has quietly confirmed, studied, and in some cases still does not fully understand, will change them in ways that don't fully show up in press conferences or mission debriefs. Some of it will show up in their blood, some of it will show up in their eyes, and some of it we still can't predict. Let's start with what you think you know about the moon. You think it's close, and compared to Mars, it is. A few days of travel, a manageable distance, the kind of journey that, after 50 years of planning and engineering, humanity has finally figured out how to make safely. That's the story. That's the comfortable version. Here's the version NASA has been quietly building data around for decades. The moon is not a destination. It is an exposure event. And the 4 people aboard Orion right now, Reed Wiseman, Victor Glover, Christina Koch, and Jeremy Hansen, are the first human beings in over 50 years to be fully exposed to what it actually does. Start with the radiation. In low Earth orbit, where every astronaut since 1972 has lived and worked, Earth's magnetic field acts as a shield. You can't see it, you can't feel it, but it is absorbing the constant barrage of charged particles streaming outward from the sun and inward from deep space, deflecting them before they reach the station, before they reach the crew. And the International Space Station sits safely below the Van Allen belts, the concentrated bands of radiation that Earth's magnetic field traps and holds. Every mission since Apollo 17 has stayed beneath those belts. For half a century, we have kept human beings inside the shield. Artemis 2 punched through both belts on the way out. It will punch through them again on the way home. And in between, for the full duration of this mission, the crew is operating outside the belts, outside Earth's protection, exposed to the full spectrum of what deep space actually is. Apollo astronauts experienced this too, but the monitoring was primitive, the instruments were crude, the data was thin. What Artemis 2 is carrying into deep space is not just a crew. It is the most sophisticated suite of biological monitoring equipment ever placed on a human being beyond low Earth orbit. Radiation dosimeters on the body, sleep cycle tracking, cardiovascular data recorded continuously. Because NASA needs to know something it still doesn't fully know. What does 10 days outside Earth's magnetic field actually do to the human body? The Apollo crews gave us hints. Several of them reported something strange during their missions. With their eyes closed, in the darkness of the cabin, they saw flashes of light, brief, sudden, impossible, like someone was clicking a camera inside their skull. They weren't hallucinating, they weren't sleep-deprived, and what they were experiencing were cosmic rays, high-energy particles from deep space, passing directly through their closed eyelids and striking the cells of their retina. The eye was registering light that wasn't there, because something invisible was moving through their heads at nearly the speed of light. We know that now. In 1969, it was just a strange thing the astronauts mentioned that nobody could explain. The issue is not just what you can feel, it's what you can't. The particles that produce those flashes are the ones your retina happens to catch. Most of them pass through without producing any sensation at all. Through the skull, through the brain, through the body. leaving behind small trails of ionized damage at the cellular level. The kind of damage that, accumulated over years, raises the risk of cancer. The kind that, in a single high-dose event, a solar particle storm hitting at the wrong moment, can cause acute radiation sickness within hours. NASA's radiation limits for astronauts are set by a calculation of lifetime exposure. Every mission adds to that total, and deep space missions add far more than low Earth orbit missions. The Artemis II crew is not crossing a comfortable threshold. They are stress-testing a boundary that humanity has only crossed 12 times before, all of them in the 1960s and 70s, with instruments too blunt to see what was actually happening. The data from this mission will directly shape every deep space crew selection decision for the next 50 years. Not because this crew is in danger of acute radiation sickness, but because we are finally measuring what we have been guessing at for half a century. Now look at the heat shield. When Orion hits Earth's atmosphere on the return, it will be traveling at approximately 25,000 miles per hour, faster than any crewed spacecraft has ever traveled during re-entry. The heat shield will face temperatures approaching 5,000 degrees Fahrenheit. Plasma will wrap around the vehicle. All communication will go dark. The crew will be completely unreachable, unable to talk to Houston, unable to do anything except sit in the silence and trust that the engineering holds. That silence lasts several minutes. It is the same silence Apollo crews knew, the same total disconnection, the same understanding that in those specific minutes there is no backup plan, no abort option, no conversation that can help. Here is what makes it different this time. After Artemis I returned in 2022, the engineers found something unexpected. The heat shield had experienced erosion that the models hadn't predicted. Sections of the ablative material, the layer designed to burn away and carry heat with it, had charred and flaked off in patterns that didn't match the computer simulations. The underlying structure held. The temperatures inside the capsule stayed within safe limits. But the damage was significant enough that NASA convened an independent review team, spent years analyzing it. Some engineers wanted a redesigned shield before putting humans on top of it. The shield flying on Artemis II is essentially the same design. The crew knows this. They accepted the risk. What they said, when asked, was something close to what every astronaut who has ever sat at the tip of a rocket has always said. The margins are real, but not infinite. That the engineering is not perfect, and exploration requires a willingness to go anyway. That's not recklessness. It's a very specific kind of clarity that comes from spending years learning exactly how dangerous something is and deciding that it is still worth doing. But here is the thing about this mission that the numbers and the engineering don't quite capture. The Artemis II crew will see the moon in a way no human being has ever seen it. Not from 70 miles up, skimming the surface, watching a narrow strip of terrain scroll past beneath them the way Apollo crews did. From 4,600 miles away, Orion will capture the entire disk of the moon at once, pole to pole, the full sphere hanging in the window. No Apollo astronaut ever had that view at closest approach. Not one of them. And because of this particular trajectory and the precise timing of the launch, the crew will see something that robotic spacecraft have photographed, but no human eye has ever directly observed: the Oriental Basin. A massive impact crater sitting on the transition zone between the near side and the far side of the moon. The Apollo missions were planned around near-side illumination. The oriental region was always in shadow or just out of frame. Artemis II's trajectory changes that. The crew has already photographed it through Orion's windows. For the first time in history, a human being looked at a feature of the moon that only machines had seen before. And then, behind the moon, traveling farther from Earth than any human being since Apollo 13, the crew will experience something that cannot be transmitted, cannot be photographed, cannot be fully described. For approximately 40 minutes, the moon will block every signal from Earth. No data link, no voice from Houston, no connection to the 8 billion people on the planet behind them. Just 4 people in a metal capsule 250,000 miles from home, in a silence that no amount of training can fully prepare you for. The Apollo astronauts knew that silence too. It is, remarkably, one of the few experiences that hasn't changed between 1972 and today. Victor Glover will be the first person of color to travel beyond low Earth orbit. Christina Koch will be the first woman. Jeremy Hansen will be the first non-American citizen to go this far from Earth. Apollo was exclusively American, exclusively white, exclusively male. Not by explicit exclusion, but because the pipeline that produced military test pilots in the 1960s was itself exclusionary. Artemis II doesn't erase that history, but it does mean that the first humans to see the moon up close in more than 50 years look more like the species they represent. They will splash down in the Pacific Ocean around April 11th. Recovery ships will be waiting. Divers will approach the bobbing capsule, open the hatch, and help 4 people climb out into sunlight they haven't seen directly in 10 days. Those 4 people will have done something that nobody alive has done. They will have traveled farther from Earth than any human being since 1972. They will have been exposed to deep space radiation that 50 years of missions have carefully avoided, and they will have watched plasma wrap around their spacecraft at 25,000 miles per hour and waited in silence for the heat shield to hold. They will have seen the full disk of the moon. They will have seen a feature of the lunar surface that no human eye had ever reached before. They will have floated in the deepest silence that our species has ever known. And they will come home changed. Not visibly, not in any way you would notice watching the press conference, but in their cells, in their eyes, in the data streaming off their bodies that researchers will spend years analyzing. Something will have happened that cannot be undone. The moon does that. Deep space does that. It doesn't care how advanced the spacecraft is, how sophisticated the monitoring, how many decades of engineering went into the toilet system, or the flywheel, or the heat shield. At 250,000 miles from Earth, in a metal shell with a parachute on top and a heat shield on the bottom, you are still a human body in a place the universe never designed you to be. Apollo proved we could leave. Artemis is learning what leaving actually costs. And the 4 people floating behind the moon right now, in the silence, beyond the signal, farther from home than anyone has been in half a century, are paying that cost so that every crew that follows them pays a little less. That's not nothing. That might be everything. Thanks for watching. I'll see you in the next one.